Okay, good morning to everybody. Is it audible?
Good morning, sir.
Is it audible?
Yes, sir.
Okay, my voice is clear, right? Okay,
Yes, sir.
so I am going to take a lecture outside of Vallabh, right? So if there may be some problem like a connection issue, so bear me because I am at my hometown now. So I am taking a lecture from there. So if you may have some problems like as a connection problems, you let me know, right? I will try to solve from my end. Okay, so let's start this lecture. Especially we are going to start. I'm going to share my screen with you, and then I will just let you know about what we have covered last time and what we are going to cover this time, right? So I think Sony sir have already taken the lecture yesterday, right?
Yes, sir.
Okay, fine. Okay, so good morning to everybody. Last time we have covered the various topic regarding the signal and system, how the core structure we have defined. There are 5 chapters are there, starting from introduction to signal and system. Then we have discussed about the behavior of continuous time and discrete time signal and the properties of signal and system. We have even described the difference between signal and system. Then we will discuss about the Fourier series, Fourier transform, convolution property, and jet transform. I have even suggested you 2 books that we are going to use as a reference book. The first book, Signal and System, written by Oppenheim, and the second book, Signal and System, written by the Anand Kumar, right? And then I have even suggested that Oppenheim book is a very, very good book if you want to go for a theoretical approach. But if anybody is interested for example point of view, then the second book written by the Anand Kumar, which one is the best one? So this part we have already discussed. I think it's visible and audible too, right?
Yes, sir.
Okay, fine. So now then we have discussed about the impulse signal. We are going to start the session for a various basic signals like starting from impulse signal, unit step signal, ramp signal, sinusoidal signal, exponential signal, sigmum signal, sync function, and Gaussian signal. Right. So these are the things that we are going to discuss in the consecutive lectures. So first we have started with the impulse signal that we have already covered last time. The impulse signal is basically then before starting with the signal, we have discussed about the continuous time signal and discrete time signal. The continuous time signal is a signal in which the amplitude of the signal is continuously changing with the time. So if we are able to discretize if we are able to discretize this time domain in infinite intervals, so every infinite interval we have a unique amplitude, so that is known as a continuous time signal. And how we represent the continuous time signal mathematically and graphically, that we have described. Graphically it can be represented as a continuous time signal. Mathematically it can be represented as a some mathematical function in which every times you feed up the value of time, and then you are getting the individual value of a amplitude. So this part we will discuss. Then we will move forward for a discrete time signal. So in discrete time signal, the time domain is defined as a discrete intervals, and this discrete interval is known as a sampling time ts. So every sampling time ts we can have a one sample. And how we represent the sample? We can represent the samples with g of nts, right? G of nts. And that means the value of g of t signal at nts time period and ts time period, right? And how we can define mathematically the signal? So we can define mathematically g of t is the addition of all the samples starting from 0 to n, g of t minus nts, where g of t is represent the signal and nts is represent the delay of a signal, right? N times, it's a delay by n time period, so it is known as a g of t minus nts, right? This is known as a discrete time signal. And the difference between continuous time signal and discrete time signal is observed as in continuous time signal, for every time interval we can have a unique amplitude. where in a discrete time signal, the time axis is divided into discrete time intervals, and for every discrete time intervals we can have a unit amplitudes of unique values of amplitude of a signal. So this is the basic difference. Then we will move forward for impulse signal. Impulse signal is a signal which which is present at only one time instant, and its amplitude is generally considered as a 1, right? So it can be present at only one time instant, and all other points of the time instant, its value is a 0. And this is a very interesting and very useful signal whenever we want to convert the analog or continuous time signal into discrete time signal. So the main application of impulse signal is to convert the continuous time signal into the discrete time signal. So we can see here, if we find the if the another property is a very interesting property of the unit impulse signal, is that if we have any function g of t, and if we take the area of g of t and delta of t, right? If we take the integration means we are taking the area, we are considering the area. So if we find the area of any function g of t with the impulse signal, right, then it gives the value of that signal where the impulse is present, right? Impulse is present. So if the impulse is present as t is equal to 0, so it will gives only single value of the function g of t at t is equal to 0. So we can say this is nothing else but is the value of g of t at the time t is equal to 0. So this part we have already done earlier. Then we have even described that if any signal g of t is multiplied with the d of t, delta of t, so delta of t is a 0 at all other instant of time except at t is equal to 0. At t is equal to 0, its value, as t is equal to 0, its value is a 1 or a, and all other points it is sorry, it's a 1. You may consider it's a 1, and all other places its value is 0. So if any signal g of t is multiplied with that value, right? If any signal sorry, it's a, right? If you're considering it's a, so if any value on any of the signals which is multiplied with this delta of t function, so delta of t would be a 1, would be a 0, and it would be a 1 at where the impulse is present, right? So all other points after multiplication, it makes all other points value are 0 except where the impulse is present. So impulse is present as t is equal to 0, so only that value is obtained as a. So it gives the value of function g of t at t is equal to 0, right? So that's part we have done. We have even described if we have not only a single impulse, but we can have a multiple impulse signals are there. So that is known as a train of impulses. So the train of impulses can be represented as a delta ts of t is equal to the addition of all the impulses from minus infinity to infinity delta t minus nts, where nts shows the different delay of the signal. So this part we have covered, and we have even discussed about what is the major applications of a unit impulse signal, that is to convert the continuous time signal into the discrete time signal. Then we have given you an example in which there is a one continuous time signal like a sinusoidal signal, and if it is multiplied with the train of impulses which are present at a discrete time interval with the magnitude of 1, then after multiplication we are getting this discretized version of the signals, right? So only the points at which the impulse is present, it will be after multiplication we are get the value of the signal g of t only at the points where the impulse is present. So if the impulse is present at ts time period, so we can have a value of g of ts. If the impulse is present at a 0, then we can have a value of g of 0. Then 2ts, we can have a value of g of 2ts, and all others. But between the 0 and ts, the impulse is not present or impulse is absent. So even though g of t is present here, it will be multiplied with all the 0 values. So that's why we are not getting any values between 0 and ts. We are not getting any value between ts and 2ts and ts and so on. So between the two sampling interval, we are not getting any values. But at the sampling interval, we are getting the value of signal g of t because the impulse is present over there. Then we have defined, if we are taking the area, if you find the integration of the unit impulse signals, then we are getting the unit step signal. We have concluded the last session over here that how to represent the unit step signal. So now in today's lecture, basically we are going to discuss about how the unit step signal does present, right? So our discussion is basically start from this one. Okay, I think it is visible. So now we are going to discuss about the next one is the unit step signal. Unit step signal, right? Very importantly. So I think my voice is clear, right? Glitches and all these things are not present in my voice.
Yes, sir.
Okay, fine.
Yes, sir.
Right. Okay. So now we discuss about the unit step signal. So unit step signal, first we just describe the unit step signal for a continuous time signal as a continuous time signal, and then we describe the unit step signal as a discrete time signal. So first we define as a continuous time signal, right? So unit step signal is a signal which basically start from some point, from some point it's a zero, right? And then it is a one. There is a impulse is over here, right? It transit from 0 to 1 on this point if t is equal to 0, and then it will be remain one continuously, it will be remain one forever, right? So forever means if you find here is some points over here, it's an infinity point, so all this up to the infinity, it would be a one, right? So that's why it is known as a unit step signal. But if you consider this area, if you consider this area, which is the area, so this area is the area where that you can find that t is greater than 0, right? So time is greater than 0, I mean positive, the value of time is positive. So you can find the unit step function u of t would be a 1 over there. But if we consider the area over which the it's t less than 0 means a negative area, so all these points u of t would be a 0. So we can say u of t signal, unit step signal, mathematically we can represent as it is 1 when t is greater than or equal to 0, right? If t is greater than or equal to 0. But now all other points means when the t less than 0 or t is negative, so the unit step function does not exist, so it will be a 0, right? It will be a 0. So this is the main characteristic of unit step signal. Now we think about the application of unit step signal. So unit step signal is basically applicable or used whenever we have to make any signal to start from 0. So if we simply multiply with the unit step signal, if you want to multiply with unit step signals, so all other points of the signals below 0, below t or t less than 0, that becomes a 0, and the signal above the t equal to 0, it remains present. So that is known as a unit step signal. And let's take one example so you may have idea. If I have a one signal, right? I have a one signal, and this signal, let's define this signal is a continuous time signal, and let's define this is a cosine wave signal, right? So I just define here it's a cosine wave signal, and the cosine wave signal is just basically start from here, right? This is a cosine wave. So if you observe this signal does present at all the points from starting from minus infinity to infinity, right? Minus infinity to infinity. And this signal is our g of t signal. How we define this signal? So that can be defined as a cos omega 0 t, right? This is a signal. Now I need some portions. This portion is this point is the 0 point, so we can say it's a t is equal to 0, and this portion is known as a t greater than 0 portion, and this side, left side, we can have a portion that is known as a t less than 0. Now if I'm interested for only this portion, I'm interested for only the portion, this portion, right? All the points I need, which are obtained at t greater than 0. But I don't want to consider this all these points which are t less than 0, right? So the better idea is that we can multiply with the unit step signal. So this signal is simply multiply with the unit step signal like this, right? This is a unit step signal which is one from t is equal to 0 to all the points which are above the 0, and it is 0, all these points are 0 for all the values of t less than 0. This is unit step signal, okay? So we simply multiply the both the signal. So if here somewhere, if you multiply this signal, this is the g of t signal and this is a u of t signal, and if we give the multiplication over here and this point, if I consider here, now what happens in this case? all the points which is below 0, all the points which is below 0, it is multiplied with the 0 0 value of unit step signal, so it makes them 0. But all the points which are above the 0 of g of t, it is multiplied with 1, right? It is multiplied with the u of t signal, and u of t is 1 in this range. So it is multiplied with the u of t, which makes them which do not change their value, because if you multiply something with 1, so it means it doesn't change its value, it remains as it is. So after the multiplications, whatever the signals that we are obtaining here, this signal is simply start from 0. It start from 0, right, like this one. And here this is the point where the t less than 0, so we have no any values, we have no any points, we its amplitude is 0. So that is the g of t multiplied with the u of t functions, right? So u of t function is very important function if you want to change the shape of a signal. You want to forcefully make them to start from t is equal to 0 or some other points, right? And you want to make it to start from some points, and then the signals should be coupled throughout the times. So that function is very useful function. So that function is known as a u of t function. Okay. Now, if you observe this signal, if I take the differentiation of this signal, right? So what you observe over here, at t is equal to 0, the signal does transact, it takes a transition from 0 to 1, right? It obtains the value of 0 to 1. Suddenly it obtains the value from 0 to 1 at this point. But after this, after obtaining this value, it remains on this value throughout the times. So if somebody will take the differentiation of the signal on this point, so you are getting some transition, so that is getting is a unit impulse signal, right? Unit impulse signal is transition, it's a simple transition for only single point. So this is the same thing. So observe at t is equal to 0, t is equal to 0, you observe the transition from that signal from 0 to 1. But all other points after this, you are getting the value becomes a constant. So if you take the differentiation of all this value, if I take the differentiation of u of t, right? So at t is equal to 0, right? So what you are getting? You are getting the unit impulse signal, right? But if I am getting the differentiation of u of t for all the points where the it's larger, means t greater than 0. So this is the portion over there, right? This is the portion where the t greater than 0. So in this case, the unit step function becomes a constant. And if you take the differentiation of any constant value, then we are getting the 0 value, right? So it's simple. What it simply tell us, if we are taking the differentiation of a unit step signal, then we are getting the unit impulse signal. So differentiation of a unit step signal will give us the unit impulse signal, right? And earlier what we have learned, that the integration of a unit impulse signal, that will give us the unit step signal. So this two relationship that you always have to remember, that tell us if you are taking the integration of unit impulse signal, that gives unit step signal, right? And if you are taking the differentiation of unit step signal, that will be give us the unit impulse signal. So that is very interesting relationship. And yeah, one very important part that you need to notice over here, when the impulse is present, what is the location or where it is locate. So where it is locate, or what is the location of unit impulse? So the location of unit impulse is the point where there is a transition from 0 to 1. We don't have always a transition at t is equal to 0. Later on, we will discuss unit step signals may even start from any other points, like is it t is equal to 2, t is equal to 3, right, after shifting. So that we will discuss later stage. But at this stage, you understand the things that if we are taking the differentiation of unit step signal, so it will give us the value of a unit impulse signals. And what is the location where the unit impulse present, at which the transitions occur, if the transition is occur at t is equal to 2, then unit impulse is present as t is equal to 2, right? So this part that you need to consider. Very interesting. Okay, now as we have discussed earlier, we will go one by one all the signals. So we have discussed about the unit impulse signal, then we have discussed about the unit step signal, and now we will discuss the third signal is known as a ramp signal. Right? We will discuss about the third category of the signal is known as a ramp signal. So as we are going to start with this signal, ramp signal. We should know that this signal is actually shows the linear relationship, right? Linear relationship. If you have any signal like this one, which continuously move, right? Which if the signal is continuously move like this way, right? And if this is my time domain t, right? And this is my signal g of t. So if it is continuously move with the time, its amplitude and this release this amplitude and time domain both will be linearly moved, right? If it does linearly move, then it is known as a ramp signal. And ramp signal is simply defined as a g of t, or if you define as r of t, it's simply defined by r of t. So that tell us the value of r of t means this shows the amplitude, and it shows the amplitude of r of t is always t, always t. It means if I pick up any point over here on time axis, let's say I pick up the point as 1, right? And if I find what is the value of amplitude at t is equal to 1, right? Then I extend my line on this slope, and if I find some point over here, so that also reflect the same value, 1. If I am interested to find what is the value of the amplitude when I choose the point somewhere here as a 3, right? So it means t is equal to 3. So that one is I extend this line over here and then extend this line on a y-axis, so I get the same value 3, right? So it simply means the value of the ramp signal r of t would be equal to the value of t. It means the amplitude of r of t is equal to the value of the time domain axis, right? The same over here also. If I pick up any point as a -1 and I extend the line here, so I get exactly -1 over here. And if I choose t is equal to -3 is a -3 point, so if I extend this over here, then I get the exactly value as a -3, right? So this is the ramp signal. So ramp signal, the amplitude of ramp signal is directly proportional with the value of a time axis or x-axis, right? Whatever the value of x-axis, the same value we are getting of a y-axis. So this graph is simply known as a linear graph. And what is the property of linear graph and all these things that we will look at after some lectures. But this is a linear graph. And why it is a linear graph? Because at any of this line, at any of the point of this line, if you find the slope, then the slope always give us the same value, right? For example, if I choose what is the slope now? Slope is the value of y2 minus y1 divided by x2 minus x1. So what is the y2? Y2 means this one is my y1, and this is my y2 value, right? Corresponding to the y1, what is the value here? It's my x1 value on x-axis. So that's why it's known as a and first point. So it is a x1 value. And the second point on axis, I choose this x2. And corresponding to this x2, we can have a y2 value. So now we can have a pair of x1 and y1, and the another pair, corresponding pair, is x2 and y2. If I find the slope on this point, so slope is simply defined by the distance the between the y-axis or vertical movements of graph on a y-axis divided by the vertical horizontal movement of the functions on a x-axis. So if I take the differentiation of y2 minus y1 and x2 minus x1, that simply give us what is my x1 here? X1 is 1, right? And y1 is also 1. That is x1 y1 pair. And what is the pair of x2 y2? So x2 I have taken 3, right? And corresponding to this 3, the value on y-axis is also 3. So that is also 3, right? So my x2, y2 is also 3. So as I put all this value here, y2 minus y1, so it is 3 minus 1, and this x1 is also 3 minus 1. So that tell us this value is just 2 divided by 2 means 1. So what is the slope of this one? The slope of this ramp function is considered as a 1. So in some of the generalized form, this one is rather than directly write the t, this function is sometimes written as a slope multiplied by t. Here we have a slope is 1. So rather than writing 1 into t, we simply write it is equal to 1. But this is not the case all time. Sometimes the ramp signals doesn't have the same slope. It can have a different slope. So here it is necessary that we have to write this equation r of t as a slope multiplied by t, right? So that way we have to write. And the slope remains a constant for any other point. If I can choose this one as my x1, this is my x2, right? And correspondingly, I find this is my y1 and this is my y2. And for that one, for those points, if I write x1 y1, so that is of minus 1 and minus 1, right? And what is my x2 y2, so that is of minus 3 and minus 3. And in those cases, if I find the slope is y2 minus y1 divided by x2 minus x1, then this value give us minus 3 minus minus 1, right? Then this value is again give us the minus 3 minus minus 1. So if you cancel it out, because all things gives the same value, that we get is 1. So here we are also getting the slope 1, right? And for here we are also getting the slope 1. And this can be happens for any 2 points. If you choose any arbitrary any 2 points x1 and x2, and correspondingly you find the vertical axis value y1 and y2, and if you find the slope for any of the 2 point of this graph or of this linear line, then you can have a same slope, right? So that's why it is known as a linear function of time, because the slope doesn't vary over the time. It's not like as a parabolic function where the initial slope found is a lower value, and as the value of t will progress towards the infinity, we can have a higher value of a slope. It's not like that. It can have any 2 point if you pick up from 0 to infinity or from minus infinity to infinity. So for every those points, we can have a same value of the slope or identical value of the slope. So this is the very important things that we need to notice over here, and that's why this is known as a linear ramp signals, a linear functions of a time, right? So this is very importantly that we need to know now. Now at later stage we will came across some other ramp function which doesn't have a the value of slope is equal to 1, but make notice here, any of the ramp signals we are choosing, they may have a the value of slope is equal to 1 or value of slope may not equal to 1, but the value of slope will remain constant throughout the times, will remains a constant throughout the times. So that is the part that we need to notice. Okay, so now this is what we have covered is a ramp signal, right? And now we will discuss about the next very important signals that you always have to be came across, and you are very important. You have even very good exposure about this. This is sinusoidal exponential function, and then we discuss about the sigmund function, right? So now we discuss about the sinusoidal function. So now as we discuss about the sinusoidal function, so sinusoidal function, it means either it can be represented by the sine value or it can be represented by the cosine value. So they may have two variants. Either it may be a sine or it may be a cosine signal, right? So if we talk about the sine signal, then we can say the sine signal can be represented in this form. Sine signal that you are very well aware about. This is a sinusoidal signal. We are not spending too much time over here because as you are well aware about this function. So peak value of this signal is simply defined by A, and the negative peak value of this signal can be defined by minus A. This signal is our sinusoidal signal, and that can be represented g of t as a sine omega 0 t, right? So very importantly, we need to notice basically every sinusoidal signal have two important parameters which are constant, right? So what are the constant value of this sinusoidal signal? So you can notice the sinusoidal signal have a two constant value. 1 is the amplitude, right? So this is the peak amplitude, this is the peak amplitude, and this a peak amplitude is always constant, right? Even though the amplitude between 0 to t, it will be vary, but the constant value, it shows just constant value of amplitude. Peak value of amplitude is always constant. The another terms that we need to notice is this frequency. This is the frequency that is also always a constant one. If we pick up any sinusoidal sine wave or cosine wave, then its frequency is always found as a constant. So we can say this omega 0 is simply defined as a 2 pi f0, right? Now, this omega 0 is the frequency we can found in a radians, frequency in radians. And what is this value f0? This is the frequency that we can identify or we can found in a hertz, right? So this is the frequency in hertz. So we can say omega 0 is equal to 2 pi f0, where omega 0 is the frequency in radians and f0 is the frequency in hertz. And what is the relationship that we can identify between these two frequencies? Omega 0 is equal to 2 pi f0, right? This is a very important relationship that we need to note down. Now, f0 is defined the frequency of the signal. So if the cycles, if there are in this one time period, if there are 100 cycles are complete, so we can say the frequency of the signal is 100, right? And what is the time? So time period t is the time taken by the signals to complete a one cycle. So that is inversely, it is in inverse of the frequency f0 frequency. So if someone has a frequency f0 is equal to some sinusoidal signal has a frequency of f0 is equal to 100 hertz, it means in a in a 1 second 100 cycles of the signals are complete. So how much time is required to complete a one cycle? That is defined by the time period. So this time period t is defines how much time is required to complete a one cycle. So that is 1 by f0. So if I put all this value 100 here, so that means 0.01, right? It means 0.01 second, or approximately zero point 0.1 yeah 0.01 second, or approximately it is known as a 10 millisecond, right? If so, approximately is known as a 10 millisecond is the time required to complete a one cycle of the signal, right? So that way we can define the sinusoidal signal, and this is the defined as a time vector. So for each and every value of time, we can have a new value. The sine omega 0 of t have a new value, this function have a new value. So every time the g of t has some new values. So if we can define this time interval at some instant like as a 0 ts 2 ts, so for every those time period we have a different values of amplitude, right? So these are the important parameters that we need to note down. Every sinusoidal or cosine signal. I am not extending our discussion with cosine signal, but if you talk about the cosine signal, so these parameters are not going to change, right? So for every cosine signal also, we have a very important parameters are the peak amplitude of the signal, the time vector t, and the frequency of the signal. Okay, this is the part that we have to notice. Okay, so now the next category of the signals that we are going to learn is exponential signal. It's known as a exponential signal. So exponential signal is either increasing with the times or it is decreasing with the time. So if it's a exponentially, we can say it is either exponentially increasing or exponentially decreasing. If we talk about the any signal, that is our g of t signal, right? G of t signal versus the time t. So I am giving you an example in which the signal is exponentially increase, right? It is exponentially increase. Here also it is exponentially, right? So how you define this one? So we can define this signal as a e raised to a t, at, right? What is the value of t? So this is the value of t. So every time points we have a new value of e raised to at. Every time interval we have a new value of e raised to at. So that is known as a, this is exponentially increasing, exponentially increasing. This signal is increased with a time of t, so it's known as exponentially increase. Now what is the value of a over here? So a is a constant, right? This constant value is defined how rapidly the signal e raised to at is exponentially increasing with a time t. So a is a constant and it defines the rate of exponentially increasing of the amplitude with respect to the time t. Now there may be some signal which is exponentially decreasing, right? Exponentially decreasing. So if you find some signals are exponentially decreasing like this, right? So if you see if I continuously revert from minus infinity to plus infinity point, so we can say this signal is exponentially decreasing with the time. So if the time approach to infinity, this function is simply known as e raised to minus at. So this e raised to minus at is approaching to 0, right? Is approaching to 0. So is for a very higher value of time, the value of this exponential function is very smaller, very smaller. It's known as exponentially decreasing. And for here you can see this is exponentially increasing. It means if I take a is equal to if I take the t is approach to infinity, so what happens with e raised to at? This e raised to at is also approaching to infinity, right? So that is known as exponentially increasing, and this function is known as exponentially decrease, right? This graph is a linear graph or non-linear graph. Anybody of you can answer out this question? This graph is a linear graph or non-linear graph?
Non-linear.
Non-linear, right? So what is the condition of linear graph is that if you find the slope at any of the 2 points, right? So you can have a same slope. But now what happens if I pick up the 2 point here, right, at t1 and t2? So I can have a some slope. I can have a slope here. It's known as a delta 1. This is the slope. But you pick up any two other point like as a t3 I am choosing over here. Sorry, I choose the 1 point here t3, and if I elaborate this over here, right? So this point and this point will not have a same slope. So the slope, this slope, if I compare as a slope delta 2, so this delta 2 and delta 1 are not equal. So we can say any of the 2 point, if I pick up any 2 point randomly out of this whole point, so between any of the 2 points, we are have a different values of a slope. We have variable values of slope. Slope doesn't remains the same, not identical. So that we can say this function is the exponents is not a linear function of time. It's a non-linear function of time. And there are many phenomena that happens in a real in a environment that we can say this things does happens. You can say the increase the number of lions in a Gir forest. So number of lions in a Gir forest may not be linearly increased. They may be increased non-linearly, right? So it's sometimes we can say they are exponentially increasing. We can say the lung cancers in India, the number of diabetes patients in India, how they are increasing. So you can even say that is the exponentially increasing, right? So exponentially increase means increase with a more rate than linear. So linear graph would be looks like this, right? So compare if the t is approaching to higher value, then exponential increase means with increasing with higher rate than the linear graph, right? The same way something are exponentially decreasing, you can say there are many birds are there in the world, their populations are going to decrease and they are extinguished now, they are about to extinguish now. So we can say their populations of those persons are rapidly decreasing, so we can say they are exponentially decreasing. So this is a graph that we show as either exponentially increase or exponentially decrease. Okay, now next function is known as a sine function, or sometimes it's known as a sigmum function, right? So sigma function is a function which just define the polarity of any signal. So if you are multiplying any signal with such a polarity, so their polarity is going to change, right? I can simply define this sigma function is a simple function which is always positive, right? Which is always positive, right? With respect to t, if t is greater than 0, right? Right, but if t is less than 0, if here in this region where the t is less than 0, this value is negative. So this always have a only two values. Either it has a positive, like as a positive unit pulse, it has a positive value 1, constant value of 1, for all the points if t is greater than 0, but all the points where the t is less than 0, it is always shows the negative value, right? So it's just to define a polarity, because here the t is negative, so the amplitude is also negative, and in this region the t is positive in t greater than 0, so t is positive, so amplitude is also positive. So this function is sometimes defined in a symbolic form. It is defined as a sine of t function or sigma function. It is 1 if t is greater than or equal to 0, or this value is minus 1 if the value of t less than 0. So it can have either plus 1 or minus 1, and if you multiply any signal with the sigma function, that it changes the polarity. Now my question is, can this signal looks like similar like as a unit step signal? Yes, it's not exactly similar, but it may be, it can have a some similarity are there. Now, can anybody of you will let me know if I have to simulate this, or I have to correlate this with this function unit step signal, right? This is my unit step signal u of t, right? For every t greater than 0, it is 1, and for every t less than 0, it is 0. So this is my function number 1, sigmum function, and this is my unit step signal, function number 2. So can we find any similarity, or can we find any mathematical relationship between these two functions, sigmum function and unit step function? Yes. How? So if I have to derive sigmum function for the unit step signal, right? So what you consider, or differently, if I have to derive, I have a sigmum function, right? And I want to derive this unit step signal. So how you define? So idea is that I multiply 1 with sigmum function. I multiply 1 with sigma. 1 is a constant, right? So how you define the 1? So you define the 1 is nothing else, but it is the constant, or it is constant 1. This is known as a 1. This is a 1 for all this value of t. Irrespective of the value of t, it is constant 1. If I multiply 1 with sigmum function, right? 1 with the sigmum function, then let's say what happens, 1 with sigmum function. So sigmum function would be like this: t greater than or equal to 0, t is equal to 0, 1 and minus 1. So if I add both these things point by point, so what is my resultant signal? This is plus 1 and this is 1 for all this value of t greater than 0, right? So they will be added. But what happens with t less than 0? This is 1 and this is minus 1, so they will be cancel out, right? They will be cancel out. So after additions, you are getting such kind of a signal, such kind of a signal. Here we are getting the amplitude too, because both 1 plus sigmum function, sorry, 1, this is okay, so this, sorry, it's not 1, it's only 1, it's only 1, right? Function is g1 of t is equal to 1 only, right? And here g2 of t is equal to sigma only, sine function, right? So if you are both are added, so that is g1 of t plus g2 of t, and it can be represented as a 1 plus a sine function of t. This is the case. So what happens over here, that is on this portion, for every t greater than 0, there will be added. So we are getting the amplitude 1 plus 1 2, but for every t less than 0, that we can say this 1 and minus 1 will be subtracted, so we are getting here 0 values, right? So we can say now, if this is like as a unit step signal, but unit step signal which is 1, which is 1, but here it is amplitude is 2, so it is simply, it's a u of t function which is multiplied by 2 is equal to 1 plus sine of t. This is 1 plus sine of t. So what is the unit step signal here? So unit step signal is, if you divide both side by 2, so it is 1 plus sine of t, whatever the value of this, if we exactly divide it by 1/2, or multiply with 1/2, or we divide by 2, then we are getting the u of t signal. So u of t signal is simply known as a 1 plus sine t function divided by 2. That is exactly what is the relationship between sine function and unit step signal. Very importantly, you can even note down this at later stage in a Fourier series or Fourier transform. We will use it. It's very important function. So this is the relationship between unit step signal and a sigmum function or a sine function. right? Sigma sine function. Okay, so this is the part that we need to understand, right? So this is what's about the sigma function. Now we left with only two functions, and that we conclude in this session. So our today's lecture will be concluded after this. So next function is a sine function and Gaussian function. So we are going to discuss this function. Very important functions that we are going to discuss is this uh, sinc function, sinc of x function, right? That is known as a sinc of x function. What is the sinc of x function? So that is known as a sine of x by x, right? So sinc of x function, sorry, we simply write here the sinc of x function is simply defined as a sine of x function divided by the x, right? Or if you are very much very or it very familiar with the t function, so it is defined as a sinc of t function, and that is of sine of t function. So sine of t function that is divided by exactly t. And if graphically we observe this one, so that is the function which looks like this, right? This looks like this one. I better I describe like this way. This is a function which has a higher log, lower log, and so on, right? And here also has a higher log, then the log will going to decrease. So what happens? You see the lobs, the size, the amplitudes are is decreasing, right? Is decreasing, and here also this amplitude is also going to decrease, is decreasing, right? At this point where t is equal to 0, right, you are getting the maximum amplitude, right? You are getting the maximum amplitude. So why? Because at a 0, t is equal to 0, here we are getting the sinc function of 0, because then it is sine of 0 by 0, that is of sine of 0 by 0, that is both are 0 by 0, right? But 0 by 0 is neither infinity and nor 0. So what the L'Hopital's rule will tell, L'Hopital rule tell us, rule tell us, if any function s t is equal to z approach to 0, if any function fx of x, that will be lead to 1, that will lead to 1. So this function is simply we are getting the maximum amplitude here is a 1, right? So we can say as the t approach to 0, this function sinc function is also the similar function of sine x to x, that will be lead to 1, that will be lead to 1. As per this L'Hopital rule that you have already learned earlier in mathematics, that shows we are getting the maximum value of sinc function at t is equal to 0, and all other points their value is going to decrease or diminish, right? Their value is going to diminish. So this we can say this sinc function, the sinc function is monotonically is monotonically means with respect to only one variable. So we can say it's a monotonically decreasing with respect to wrt, means with respect to t, right? With respect to t, it is monotonically decreasing. This is the first conclusion, and the second conclusion that we can derive here is this: if you observe this same function, so you are getting both the sides. It's just a source symmetry. If I pick up any point here as t is equal to exactly minus t1, so it has some value, and at the same point t is equal to plus t1, we have a same value, right? If I choose any point here as a t is equal to t3, it has some amplitude. At the same amplitude, we can observe a t is equal to minus 3. So at any same point, either or the right side or positive value or negative value, we can have the same amplitude. So that means this is a very important function, and this sinc function is a symmetrical function, or this waveform or signal is just shows the symmetry, both the side y-axis side, both the sides of a x-axis, right side and left side. That is for a negative points of value of t and the positive values of t. So this is known as a symmetrical function. So this is very important functions that you need to learn over here, right? And the last functions that we are going to learn in the same course is about the Gaussian, right? Gaussian, and Gaussian is a very intelligent scientist. Sometimes when I got sometimes that we will discuss about the Gaussian function. So this is a Gaussian function, and Gaussian function can be shows this kind of a symmetry. It's like as if it's right. This is a Gaussian function. So Gaussian function is basically uniformly distributed, so it is also symmetrical function. And for every Gaussian function we can define here, this Gaussian function is simply represented as a g of t, right? And how you represent this Gaussian function? G of t is e raised to minus t square by 2. It's like as exponential but square of exponential. So generally it can be represented g of t is equal to e raised to minus t square half, right? We are assuming the mean value, right? Mean value means average value of t. Average value is 0 because here we have a if you see, there are some points on negative side and there are some points on positive side. So mean value is somewhere falls between the middle point, and middle point is 0. So mean value of is 0. And the variance, what is the variance and mean value, that we discuss at later stage, but the variance is also 1. So that is known as a Gaussian functions, right? Very important. Okay, so now I conclude this session over here. So what we have discussed so far, we have basically discussed about various function that is including as a sinc function, right? We have discussed about the various important function like as a sinc function, uh, Gaussian function. Then we have discussed about the sine function, and establish the relationship between the sine function and unit step signal. Then we have discussed about the some exponential function, positive going exponential function or negative going exponential function. Discuss about the basic function like a sine, cos, ramp signal. And then we have initially discussed about the unit step signal and define the relationship between unit step signal and ramp signal. And one more things that we I think that left for discussion is, if we take the differentiation of this ramp signal, then what happens? Differentiation of this ramp signal will give us a unit step signal, right? Because what we are taking, ramp signal is basically defined as a t, r of t is equal to t, right? We can say r of t is equal to t. So if we take the differentiation of this, it will give us a 1. So it is similar like as a unit step signal. And if the similar way, if you take the integration of a unit step signal, right? Integration of unit step signal, so it will be give us the t, or it's give us a ramp signal, right? So this is the chain that we need to understand. If we take the integration of a unit impulse signal, it will give us a unit step signal, right? And if we take the integration of unit step signal, it will be give us a ramp signal. Now we think in reverse direction. If we take the differentiation of ramp signal, it will be give us a unit step signal. And if we take the differentiation of unit step signal, then it will be give us a unit impulse signal, right? So that you need to understand. Okay, so now we are going to conclude this session over here. Now I would like to take your presence, right? Attendance. And again, I am not with my desktop, so I will take your presence on manually, and those presents will be complete, they can leave the meeting, right? Because the session is concluded over here. Okay, number 1 is present. You have to tell yes sir only. Number 1, 2, 3.
Two present, sir.
2 present. 3,
Yes, sir.
4, 5,
Yes,
6.
sir.
6 is present, right? 7,
Yes, sir.
Sir, five
8,
present.
5 present, 6 present, 7 present, 8, 9, 10.
Yes, sir.
Okay,
Yes,
10
sir.
Present,
present.
sir.
9.
9 is present,
9.
10.
Yes, sir.
Okay, 11, 12, 13,
Present, sir.
14, 13 present. Okay.
Yes, sir.
14.
Yes, sir.
Okay. 15.
Yes, sir.
6, okay. 16,
Yes, sir.
17,
Yes, sir.
18.
Yes, sir.
Okay. 19,
Yes, sir.
20, 21, 22.
Yes, sir.
Okay. So 22 is present, right? 23, 24, 25, 26,
Yes, sir.
27, 26 is present. 27,
Yes, sir, present.
okay. 28,
Yes, sir.
29, 30, 31,
Yes,
32.
sir.
Okay, 31 is present, right?
Yes,
32,
sir.
32,
Yes, sir.
okay. 33,
Yes, sir.
34,
Yes, sir.
35,
Yes, sir.
36,
Yes, sir.
37, 38,
Yes,
39,
sir. Yes, sir.
38,
38.
39, 40, 41, 2,
Yes, sir.
42, 43.
Yes, sir.
No, sir. I'm 41.
Okay, 41. 42 nothing. 41, 42 is present. Okay, 43,
Yes, sir.
44, 43 is present, right? 44, 45,
Yes, sir.
46, 46. Your number is 46, right?
Yes, sir. 45.
Yes,
45.
sir.
Okay. 45, 45, 46,
Yes, sir.
40,
46.
47,
Yes, sir.
48, 49,
Yes, sir.
50.
Yes, sir.
Okay, last number is 50 or 51 to what is the last number?
61.
61. Okay, 51,
Present, sir.
52, 53,
Yes,
54,
sir.
53. Yeah. 54,
Present, sir.
55,
Present, sir.
56,
Yes, sir.
57,
Yes, sir.
58, 59,
Yes, sir.
60. Okay, 61. Okay. Now any D2D student?
Yes, sir.
What is your roll number?
20 ECD 04.
04.
Yes.
And
23 present, sir.
23 is present. Okay. Okay. So I think all are okay. So
12 present.
12 is present. Okay. Okay. Anything? Anyone more whose attendance have not been taken? Okay. So have a nice day and good time to all of you. Right. We will meet in the next lecture.
Thank you, sir.
Okay.
Thank you, sir.
Thank you, sir.